In this video, we're going to identify rational numbers. While we're going to identify rational numbers, we're going to talk about irrational numbers as well. Let's start first with a definition of rational numbers. Rational numbers are all numbers that we could write as a ratio. So if a number could be written as a ratio, then it's a rational number. 2/3 is the first example. It's a ratio, so this is a rational number. Now let's take a look at the second one. Square root of 3 or radical of 3. What can we say about this number? Is this a rational number? Now, in order to identify the rational number in this case, we're going to take a look at number underneath the square root. And this is 3. And we're going to ask ourselves, is this number a perfect square? Which one are perfect squares? Perfect squares are numbers like 4, 9, 16, 25, 36. So 2 to the second power, or 2 times 2 equal 4, 3 times 3 equal 9, 4 times 4 equals 16. So it's the square of a number. 3, it's not a perfect square. So square root of the perfect square is going to give us a whole number. But square root of non-perfect square is not going to give us a whole number. But it's going to give us a decimal number which is non-repeating and non-ending. So in this case, this number is irrational number. The next example is pi. Pi is an irrational number. Why? Because we say it's 3.14, but then it will continue. And the digits that will continue for pi are non-repeating and non-ending. It's a number that never ends, so this is an irrational number. The next example is -3/4. That's a rational number. It's written as a ratio. As simple as that. Then we have negative radical of 8. 8 is not a perfect square, so this is an irrational number. 2 and 2/5 is a mixed number. As a mixed number, we can rewrite this as a ratio if we want. That's a rational number. Radical of 36 is 6. So that's a rational number. Radical of 72. 72 is not a perfect square. So the square root of it is not a whole number. And it's not a repeating decimal. So it's a decimal that is non-ending, non-repeating decimal. So it's irrational number. How about a decimal that is repeating? In this case, repeating decimals are rational numbers. In another video, I explain the whole thing, the whole steps following how to convert a repeating decimal to a ratio. The following number is 0.2935, and it will continue. As we see all digits 2, 9, 3, 5, they're not repeating numbers. The number will continue, non-ending. So in this case, it's irrational number. The following number, 0.525252, we can rewrite as 0.52 repeating, and in this case, this is a rational number. Radical of 144 is 12. It's a whole number. That's a rational number.